Okay, so welcome to the evening session where we'll be talking about control flow. Just to finish on the topic of control flow. So, control flow statements are basically statements that tell code where to go, rather, tell the program where should we go. Should we proceed? Should we loop? Or should we go back and repeat? So, it touched on if else, and if else if. So, if is used when you have one, if is used when you have this simple decision maker runs a block of code if a condition is true. So this one runs when the condition is true. So for example, void main variable age is equals to 10. Then now we bring the if age is greater than 18. So this is the function, the one that I violated. If age is greater than 18, you print Mariam is a voter in Kenya. Okay, this one can be ignored because it will not run, it will not output anything. So this one, this is if. The extension of it, or rather a wider view of it, is if else. So the same medium, variable age is equals to 10. If age is greater than 18, print Mariam is about in Kenya. What if she's not 18? You know? So else print Mariam is too young to vote. So that's how we use if and if else. So if else is used when we have two conditions. If else, sometimes you have two paths to choose from. If the condition is true, do one thing. Otherwise, do another. So basically, it means you must use one of the conditions in that because there are two paths. So if path one does not align, you'll definitely go with path two. So if else if. So remember, if was for if a condition is true. If else if condition is if two you have two paths. If else if when you have more than two choices to check, you can use else if you have more than two choices. For example, we still have the same scenario. Whose age 8, whose age 10, variable age 10. If age is greater than 18, print Mariam can vote in Kenya. Else if age is exact, double equal sign is exact. If age is exactly 18, print Mariam is just old enough to vote in Kenya. Else, so what if she doesn't meet any of this? Else, Mariam is too young to vote. So as you can see here, we are giving this program more than three choices to take one from, and we can see the answer. And maybe one of you can can see the answer. What do you expect here? What would you expect as the print? Just unmute and see.
Mariam is too young to vote.
Why are you saying that?
Because the variable age is 10. It is
Okay.
below the minimum.
Okay. What will be the answer for this? Just observe keenly.
Mariam is old enough to vote in Kenya.
Mariam is just old enough. Why is that?
It's the exact number.
Okay, because you can say that
Mariam can vote in Kenya.
oh, Mariam can vote. Somebody is saying this. Maybe you can explain to us why you chose
Just
this.
as you find it, your dad walks in and his stomach just drops. So you try to explain, but your dad just starts screaming. So you tell him you're sick, but But the screams just get louder, so you want the voice.
Somebody chose this. Why is choosing this? Okay. What about this? What will be the answer?
Mariam can vote in Kenya.
Yeah, Mariam can vote in Kenya. So it's just you playing with the values and your conditions. It's just like saying if maybe let's say you are in a, which example can I use? Let's say you have money. If you have money, you can buy a shoe, right? If you don't, maybe you will look for it. It's just conditions. Yeah. So now I was just trying to put you into a pace with the afternoon class. So now let's touch on switch. So switch is very, it's a bit cleaner than the if else. The if else look a bit chaotic. So in that, the switch statement is used to evaluate an expression and execute different blocks of code based on matching cases. So here we deal with case and breaks. Okay. So here we'll deal with cases. So let's just go one by one. Think of switches are more organized if else. Okay, it's more organized. Let's see. So void main, we have an integer day, which is 3. Okay. So switch, we will have cases that have to match the integer given. Okay. It's just like saying, it's just like telling this program, any case that will match the integer here, that's what you should print in the simplest terms. Okay. Let's see. Switch day. So you open this. It's actually the whole of this is a function. So switch day, enter the function case 1. Print Monday. Let's code. Then moving from case 1 to case 2, you break. Okay. Case 2, print Tuesday. Keep coding. Okay. Then we are done with case 2. Now we go to case 3. Case 3. So before moving to case 3, we have to break it. I'm sure you're seeing these breaks that separate each case. So case 3, print Wednesday halfway through. Okay. Break. So we can choose to have case 4. But now, maybe you are tired of writing long lines of code. So if it doesn't meet any of this, what do? We have a default that says print time for the weekend because it doesn't meet any of the weekdays. So allow me to take this code. Or maybe, so remember we're printing something that matches the case. Okay, let me just create a file called switch.dat. Then I paste the code. Let me just, I hope you can see the code in the LMS. You can see the answer is Wednesday half through. Why? Because we are printing case that matches the given integer. Okay? And the integer value is 3, so we are just going to print case 3 in short. That is it. If I put here day 2, what do you expect?
Tuesday.
Okay, let's see if she's right. Tuesday, keep coding. So are you seeing the way this is a bit shorter? It's, you can just by looking at the code, you can see the output. Like by looking at this code, you can see the output, right? And let's say I put here 9. What do you expect?
Time for weekend.
Why?
Because it is in the default, it doesn't meet the days. It is not on a weekday.
It does not meet any case. Okay. So for you, you just be looking at the case. If it's case 5, go where. If here it's if you have what you have here is 5, always refer to case 5. You should. Like I'm sure you would have already seen it. Okay. Like from this. Let me put 1. What do you expect here?
Monday.
Monday, because it meets case 1. It meets the case. So just in that, the switch statement is used to evaluate an expression and execute different blocks of code based on matching cases. Okay. So it's a simple way of writing an if else statement, because if else you say she's a voter, else you're writing all those things, but this one is a bit cleaner and shorter. Right? So let me also throw a question here. What do you expect here?
Tuesday.
Any other person?
Tuesday.
Okay, let's run.
Yeah.
Yeah. So it does not depend on how you arrange your cases from 1 to 10. You can even start from 10, 6, 5, so long as you meet that case. So that case is the one that's important because it has to align with the value given, the integer. So this is like saying, let's say you're printing out your marks for math, English, Kiswahili, maybe science, and you're looking for a specific one that matches. Maybe you got 60%. You're just looking for 60%. So you can have case 50, case 60, case 80, case 90. But here, you'd have put your case 60 because that's where you're looking for. Then in each of the prints, you say Kiswahili, science, English. You see? It's like, it kind of gives you a leakage already because you know the output, right? Yeah, silence means yeah. Yeah, it really gives you an output. But same to if else, because you've given this girl called Miriam 10 years of age. And you're saying if Miriam is greater than, if age is greater than 10, 18, she's a voter. Else cannot vote. So you already know that she cannot vote, but you're still proceeding to give her that option. So you can just play along with numbers and eventually you will be able to understand it. So which one would you prefer, case or if else?
Case.
Case.
Else.
Anybody else?
If else.
If
If
else.
else.
If else
And let's
is
look at if else. If else looks a bit human. Maybe somebody can say the reason why they choose if else. Why would you choose if else?
Because it's direct, if not this, then this.
Yeah, plus it's also. Any other reason?
Yeah, and also it handles all the cases. If the condition is not met, you can put like an alternative one, like else, if else, then there's an else that captures every error.
Yeah, but that one is also default. Default can be captured there. Yeah. Anyways, there are so many ways of going to town. You can use a matatu, you can use a commuter, you can run. Which other way? You can use an aeroplane. But main thing is getting to town, right? So that is it. Just like that. They're interrelated. Just like saying I can do one thing in many ways. So now today you've chosen this way, tomorrow you might choose the other way. Okay. Yep. Hmm. Looping statements. Looping means iteration, repetition. Okay. That loop is used to run a block of code repetitive. So here there is the word repetition. Okay. Repetitively for a given number of times or until it matches the specified condition. Loops are essential tools for any programming language. Loops let you repeat a block of code multiple times. They are like running on a treadmill until you reach your goal. So that we'll start with that one. Maybe in real life, what have you experienced that maybe you've done looping in real life without knowing? What might that be? What have you repeated until you achieved, or maybe until you matched a specific condition? Somebody saying a song. So were you trying to write a song or what? Do we have musicians here? Okay, it's good to have diversity. Can I choose someone? John Francis. Do you mind maybe telling us what might have you repeated until you mastered or until you matched the condition you met? Maputi Gomo. Gomo. Yeah, Vincent Karanja.
For me, it is playing the guitar and also practicing coding, most especially Python.
Nice. Patricia.
Mine, I think, cooking, especially chapati. So yeah, the procedure. So I can be able to cook in a very short time. Preparation
Maybe
and
somebody who
cooking.
doesn't know what chapati is, let me just show them. So are you able to cook for the whole class?
Wow.
Yes,
Nice. Brown or white?
all
That's
brown,
good.
white. Yeah.
Right. Thanks for that. That's interesting. Mfo Selapedi.
Hello, am I audible?
Yes,
Um,
loud and clear.
the thing that I mostly practice playing is the ukulele, which is like a small guitar with only 4 strings. I
It's
also
called
have ukulele.
ukulele.
I got it as a gift a few months ago, and I've been learning how to play it. And also, I'm very keen on learning new languages in general.
Nice. That's so good. Make good use of the gift. So nobody's saying they've given their friend a chance until they change, but maybe someone close to them a chance until they change. Yeah, do not be afraid. It's looping. Or maybe you've ever been given a chance until you change. You know. uh, Vincent Karanja. Is it true?
It depends.
Okay, depends. I think one thing I've given a chance is learning to play. Not even learning to play, playing football until we perfected it. We won some small league with my friends. Yeah, by not giving up. Yeah. Gomo, you can see your hand is up. Maybe you can have the last one.
Hello, evening everyone. Can you hear me?
Yeah, we can get you.
Yes. I was asking about a previous question with the work we were doing. I just wanted to ask with the switch cases, say you have multiple like variables, how would it work in that case? Because for the one we have, it's like one, and then you choose from the case that like corresponds with the number that's up there. So let's say I've got like two now, or maybe three. How would it work in that case?
Okay. So you see, what happens to conditions is that, or rather decisions, I can say the word decisions, is that you don't always choose two decisions at the same time. Even if they are even if they are closely related, each of them is usually decided on its own. For example, I can choose to eat and sleep at the same time. So me choosing to eat is a condition on its own, and me choosing to sleep is a condition on its own, even though they are how do you call it? They are simultaneous. Yeah. So a condition is usually one. Okay. A condition is usually one. For example, in this case, variable age is equals to 18. So we are going to refer an if statement knows where to get the condition, like it has to be one. Okay. Or maybe if you say variable, assuming you're doing something like you're trying to check if your grocery list is checked, is full, or it's what you wanted to buy at the same time. So you'll have a whole list, but still it will be one, it will be treated as a unit. So in programming, a condition is usually one. Okay, as a decision usually made based on a condition. So the first condition might be required by the second condition, but the first condition has to be treated as its own. So that here in switch, int day 9, int day is equals to 9. And also, I can have another variable, int, a variable, for example, month 3, right? Yeah, let me run. You see, we still have Tuesday. Let me put one case. Let me add one case. How do I call it? Day, comma, month here. It's an error, right? I expected to find. Just trying to see if it works. Does not accept. Yeah. So as you can see, I cannot have a switch that contains all this. It only carries one. Let me use plus. Okay, plus. Let me print. Time for the weekend is giving us time for the weekend because none of them meets all this. none of them meets, all 9, 3, and 2023. Yes, our 9 gave us Tuesday, keep coding. So let me change this switch to also have, so that 1, 3 does not accept either. So how do I concatenate this? Try removing the text. It can't. Like case has to be specific. Case has to have. Unless now your variable has to be 9, comma, or maybe 9, 9 plus 3 plus 2023, because the case here 9 is only it will only can only work with this 9 if there's no other variables. I'd say that because case is very specific. Case has to meet the given condition, one of it. So unless maybe there's an invention, but this is how case works. Or do you have a suggestion? Then you to ask the question.
So you're asking if I have a suggestion?
You're asking, right?
No, I don't. I just wanted to know if it can happen. It's fine.
Yeah, this one is a bit very specific. Like even now, as you can see, if you give it like this, none of them will be met. Unless now
Alan,
there's a way of accommodating all these other variables. I've never done that though. Let me just
unless
try.
you remove the day and year,
Where? Here.
switch here, remove a day,
Then how will
no,
you
no,
capture the two?
delete the day, remove day, write month, try running, no, delete the plus.
I think that will give us Tuesday. It will not be. What? Yeah, I think it's actually the same thing because when we put day here, it will just give us what the day gave us here, right? It's the same thing, guys. Because if I put here, there's no case 2023. Let me just put there's no case 2023. And I presume the answer will be time for the weekend. Time for the weekend. Why? Because case has to match the value. Let me put this 2023. What will be the answer? Just guess.
Wednesday.
Yeah, because the case meets the value. Yeah. So what I don't understand is can we really have another switch statement inside a switch, outside the switch?
Dennis, Alan,
Uh-huh.
there the case,
I think you can.
let me share my screen.
Okay. Super. Get it.
Are you able to see my screen? Alan?
Maybe you can give us the full view.
You see here,
Yeah, I can
this
see it.
first case. You see this first case? The integer is day 1, month 1. If you print the case, you'll see hello? Are you able to see to hear me?
Yeah, and the students can confirm if they can hear you.
Yeah. If I print the case, it will shows it is new year. So maybe if you can change these days, you put here 2. You write it as a list instead of switch.
I feel like that's a lot of work. Like you can just use if else.
Maybe.
Is it just me who prefer an if else? Maybe you can share with us the code.
Okay.
Just share so that I can push to the GitHub repo. Yeah, I'll share the repo, guys. Don't worry. So it seems everything has another way of handling, but I feel like it's very long. Even each case having its own list, and I'd prefer events. I don't know why. Yeah. So let's now look at loops. So we said loops are iterations. You repeat something over and over again until for a given you can repeat it for a given number of times or until it matches the specified condition. Loops are essential tools for any programming language. So that for loop. So the for loop is used when you know how many times a block of code you can repeat. So let's say you know how many kilometers you can cover in a day if you're doing morning runs. If you reach that, you can say I've achieved. Right? When you know when you know exactly how many times you repeat something, use a for. Okay. So, for example, this guy here, void main, you open your function, you get inside. For, so this is a inside the main function we have the for loop, which is also fine. For the parameters of this function are int I, which is integer I, is equals to 1. Okay, integer I is equals to 1. And then I is less or equal to 5. And then integer plus plus. So let me now explain this step by step. We already have this integer called 1, I, whose value is 1. And we want to loop this guy so that we want to loop it to a condition whereby the integer is less or equal to 5. So we already know how many times we should be looping. Like we should be either less or equal to 5. Okay? We should be less or equal to 5. Then, for us to continue now iterating, we have to increment our I. It was just 1. So I plus plus means iterate it. Now increment it plus 1. What will type you to do it? And from this, so if you have 1, you have 1 in your book, you've written 1, and you want it to loop, or rather to increment to a point that it's less or equal to 5. Which value will you stop at? Which value will you stop at? Okay, let me show you. Let's pass it out. You already had this guy 1, okay? And we are looping it to a number of times that we know already. And what do we know already is the number of times you're supposed to loop when I is less or equal to 5. So when we are less or equal to 5, that's when we will stop. Okay? Then for us to be able to iterate that much, for us to be able to move to the next value from 1 to 2, 2 to 3, we have to do incrementals. We have to add 1 to 1, 1 to 2, 1 to 3, and 1 to 4. Like in short, you're moving from 1 to 2 to 3 to 4, 5, all the way to a million. But you already know how many times you should stop, right? I don't know, is it confusing? Okay, let me change this. 9, okay? We'll stop when it's at 9. Let me explain this code using conditional statements. A simple loop that prints numbers from 1 to 9. So here is our integer 1, integer I, which is 1. So for us to now know that we should we loop to a point that
Yes, we have 1. So tunaenda mara 8. Sikuwa nimekosea.
yeah, like now, which will be our last value. It will be okay. Let me just say we loop to a point that our I is less or equal to 9. That's what I less or equal to 9 says. Then we increment I by 1 in each iteration. So let me ask, which number is less or equal to 9?
8.
Next. Which number is less or equal to 9?
9.
9. 9.
Anybody else? Who's saying 9? Just raise your hand. Who's saying 9? Okay. Victoria Mwende is saying 9. Okay. Yango. Which number is less or equal to 9?
Okay, this is a tricky one. Any
It's
number
tricky.
below 9, any number below 9 is correct. Any 9 is also correct because it's equal to 9 also. So 9
So
or
which
any
number?
number below 9.
So it's basically 9. Like 9 is the value. You know, 8 is less than 9. Can I search it? Which number is less or equal to Any number that is less than or equal to 9 satisfy the condition. So even 1, okay, even 1 would satisfy.
So I was
But
right.
now, yeah, even 1, even 8, even 7. But now, the tricky part is we need to loop to 9. We need to loop to 9. Okay? We need to loop this guy to 9. Hence, the output 1, 2, 3, 4, all the way to 9. If I put here 8, you will get 8. It will go all the way to the value given. Remember, it's incrementing. So that's how to use the for loop. You know the number of times I'm supposed to run. So when I reach there, I stop. See? Yeah. Maybe you can ask me some question in regards to this.
Kindly repeat, why are we not having the 9 plus 1 after we get to 9? I think I didn't get that.
Okay. The reason why we are not having 9, the reason why we are not getting 10 is because we loop to a point that our I is less or equal to 9. So long as we're just at 9, we stop there. So we do not increment beyond 9.
So that the number that is less or equal. Oh, okay. I see. Thank you.
Yeah. Because now, do you know that we can even stop at 1? We can stop at 2. But we need to, it's like making it exhaustible, like I have to satisfy it completely. So instead of me stopping at 8, let me stop at 9 because it's the last one.
Can I just ask something? Removing the greater than sign, will it yield the same result? Yeah, if you have it like that.
It's an error actually.
Okay.
Yeah. What if I put which the number is greater or equal to 9? I might have an infinity.
Infinite loop.
In fact, it will not even be equal. It's infinite. And also it brings us to for loop is used when you know how many times you are iterating. So why would I give for loop and infinite loop? Like sure, it's supposed to take me to where I want, not to where I don't want, to where I don't know. It gives me what I know, not what I don't know.
Does that have range?
Range.
Yeah.
I think that one depends on your memory, on the back. But there's no range. Unless now you say, if you want it to be an infinite, okay, infinite loop is just endless. So the range now, these now are the ranges, less to 9, equal to 40. These are the ranges. And as today is, it's hot. There will be no escape route. But it's not bad. So explanation is we repeat this code 5 times, and each time we let you know that iteration, what iteration you are on. Yeah? Okay. That for in loop. The for in loop is similar to for loop, but different in syntax. So these guys are closely related, but they're just different in syntax. It iterates through an object's properties. So what do we know about an object? It's a list. It's an array, right? It iterates through an object's properties. Then that for in loop accepts an expression as iterator and iterates through the elements one at that time in sequence. So this guy visits each element in your list or in your object. It visits each one of them. If you want to look through items in a list, a for loop is handy. Let us see. The for in loop is slightly different from the loop, from the syntax, right? It's only the syntax. So what it means, we open our function, var list 1 is equals to 10, 20, 30, 40, 50. Then for var I in list 1, so for integer in list 1, this one is to print the list elements. You print I. So this guy visits your list and goes through each one of them by printing them. Instead of being general, it goes it digs, it goes, it visits you one by one. You see? You see the way it's outputting. So are we together up to this point where we have variable list 1 is equals to 10, 20, 30, 40? Are we together up to here?
Yes, we are.
Yes.
Oh, yes,
Somebody
I am.
else?
Mine is just to ask, is writing variable a must, or we can just write list 1 and make it an array?
You know, now, we think we are storing this list, right? So the best you can do is have it as a variable. Okay? That's the best way, just to make it clear. The best way. Is it okay?
So it can't work without writing variable.
It can work, but now how will it? Like you want it to be list?
No, I don't want. Don't write list. Just where you grab it. Yeah, that way. Can it work that way?
No.
Okay.
You see now this is a variable name and this is its value. You see?
It doesn't automatically tell it's a variable.
No. Unless you tell it should be a variable.
Okay.
It's just like saying name is equals to Ken. You know, you're trying to store Ken in name, but you're not telling name it should be a variable. So it has to be a variable or a list. So are we all together up to number 6?
Yes.
Yes.
So now let's start our for in. So for, remember this is also a function. Anywhere you see something like this with parentheses and curly brace, that's a function. Okay? For var I in list 1. So variable I in list 1. So that means for I, which means an integer, okay, in list 1, print I. So this for in loop will go into this list, go integer by integer. The first one is 10, the second one is 20, third one is 30, 40, 50. Then you print I. If you say print list 1, you will have the list printed in form of the way we print the just like a triangular, a rectangular display. But this one now prints one by one. It visits the list and prints each element one by one. Are you seeing the way this one is? Okay, let's first have the first one, then I'll just give the second one. Let's see if we'll have 10 all the way to 50 vertically. Yeah, because we are printing I. See. So conventionally, how do you always print out our list? Like how do you always print out a variable? Just print the variable. Then we get the variable. So instead of us printing this, it's just the same. Instead of us, this is what we did in the afternoon. We just printed this list like this, but now we want now to print each element in the list. That's where now value. That's where now for input comes. Let's have a look and digest it.
Okay, can I ask a question?
Oh yes.
I'm sorry about the background noise, but can we use another letter instead of I, or is it supposed to be I?
I can use another letter. And I use A. It's the same.
Okay. Okay, I was just curious.
It's just like saying, you see the way that we are used to using X and Y.
Yes.
I want us you can use K and L and it still work. So what we should just say, what we should just note about this for in loop is that it goes inside the loop, the list, and prints out the element one by one. Okay? Yeah, in fact, I stands for each item or integer in the list. Yeah. In fact, the best one to use is item. So just not to confuse yourself. Yeah, yeah. So that is it. For in loop. So let me ask a question. Let's say you want to write a shopping list, but you want to run it and it should display vertically from top to down. Which loop will you use?
Point.
Yeah? Come again?
I think the following loop,
Why the for in?
because it goes inside the list and prints them one by one in a vertical manner.
Yeah. So for in loop visits the list and prints it one by one. Okay. So yeah, not bad. I'm sure it's not bad, right? So let's go to while. That while loop. The while loop is used when the number of execution of code is not known. This one, we use it when you don't know the execution. Now, how many times will this code be executed? It will execute so long as the condition is true. So long as it's true, it will continue executing. It's like you playing a game. If you win more coins, you unlock another level. If you win more coins, you unlock another level. It initially checks the given condition, then executes the statements that are inside the while loop. Okay? If you need to loop until a condition is false, use a while loop. Okay? So this is like it's like simplest. It's like repeating a task until you are done. Let's say you're washing clothes. Okay? So the first one you soaked, you use soap. Now, so long as the clothes are still dirty or so long as they're still under wash, you continue washing. But once you're done washing, what next? You don't wash it, you hang them, right? Or you dry them. So this is like repeating a task until you are done. Okay? Until you are done. Let's draw this guy. All right. Variable list one. I hope that you already know that void main, you can't escape it. We'll use it. So variable list one is equals to 10, 20, 30, 40, 50. So we have this, we maintain the same list. So integer I is equals to 0. So we initialize the index. We are starting at 0. Okay. While I, which is 0, is less than list one dot length, is less than the length of this list. Loop until I is less than the length of the list. Okay. Then we print. So we are going to loop until I is less than the length of the list. So what's the length of our list? Assuming we don't have spaces, because spaces also count like the character. So 0, 1, 2, 3, 4. So we have 4. So while I is less than the list with one length, so basically saying we're looping until it's less than the length of the list. Then we print list 1, then the current element and index I, which is 0. So in this case, in short, we are printing the current element at index I. So our index usually starts from 0. Okay? So we'll just be printing the current element at the index I. Then we now increment the index from 0 to 1, 2, 3, 4. So let's first see the output so that it can at least be more realistic. Even after I've removed the decimal places, spaces, I'm quite sure it has changed. So this is the best I can say that while. Yeah, that while. So let me just run it first so that you can explain. So, in short, wait. So in short, we are just printing the whole list. 10, 20, 30, 40, 50. We are looping until I is less than the number, the length is less than the length of the list. So, us printing each element is just like saying use for in loop, but now I'm using while. Okay? So what do I do since I'm using the while loop? I'm gonna loop until until I get to false. Okay, I get to false. So what's the first element that we're gonna print? We print element that's in index 0, which is 10. Then after printing 10, remember we are incrementing. 0 plus 1 is 0 plus 1 is
1.
1.
So we've already
1.
printed the index of 0, which is 10. Then that's I. Okay, print list I, which is 0. Incrementing, we go to 1. Which index do you have as 1 here? We have 20, right?
Yes.
0, 1, 2, 3, 4, all the way to 5. So until we complete the list in short. So if maybe we had something like 16, this thing will continue working until it's false. It will continue working until it's false. So once it reaches 60, it does not go beyond 60 because there's nothing beyond it. You don't have another value. So it only works until you get to false. So you see, I was index 0, so I printed out myself, which is 10. Now I've added 1, so I need to print out index 1, which is 20. You see, so on, so on until you get to the last index.
Don't we need to put the integer I in brackets to access the indexes?
And this is it. You see this one. Print list 1
Okay.
and index 0 because I is 0, right?
I see it now.
Yeah. So the whole trick is actually in number 6. Are we together? If somebody has understood it differently, feel free to share. Feel free. Can you go to the next one? Can you go to the next one? Or you are wondering?
Sure.
Let's look at the next one if they are related. To bring the point more close or closer. It's nothing like more close. Oh yeah. So that do while. That do while. I hope you guys you drank the evening tea so that you don't get hungry. I know some of you are making supper. So that do while loop executes a block of statement first and then checks the condition. If the condition returns true, the loop continues right away. So this guy checks, it executes a block of statement first checks the condition. If the condition returns true, then the loop continues its iteration. It is similar to that while loop, but the only difference is in the do while loop, a block of statements inside the body of loop will execute at least once. I don't know. We have like 3 remaining. Don't worry, I will not take much of the time. So that do while executes a block of statement first and checks the condition. So if it's given a green light, it proceeds. So if it's not given a green light, it stops. Okay. It executes the loop statement and then checks the given condition. So here we have void main. Inside the function of variable a is equals to var maxnum is equals to 10, which is the variable maximum number is equals to 10. Do print the value is a, then a plus 1. A is equals to a plus 1. This is like increment, while a is less than the maximum. So we already know the maximum number is 10. So we are not supposed to go beyond 10. Okay. Okay. I think if you run it and seeing what it says is better than just saying it. I think this one is 10. Okay. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So we've done 9 iterations. Simply because A is only working while A is less than the maximum number. Okay. Do while. Do it. Okay. This is an English statement that says, do it while. This is it. Do it while this is met. So you just continue doing all this. So long as you can do all this, do it while you are below the maximum number. So you can continue iterating yourself all the way, but so long as A is less than the maximum number. And the maximum number is 10. So we are supposed to iterate ourselves. It's true, it's less than the maximum number, it's less than the maximum number, less than the maximum number until now go to 9. So 10 is not less than 10. 10 is not less than 10. This one is increment. Okay. I think this one is a bit better. What do you say? Because this one, it runs the first one. Then before it goes to the second one, it checks if it's true. Then if it's true, it goes to the next. If it's true, it proceeds. If it's true, it proceeds. If it's true, it proceeds all the way to the number now that if I go to the next one, I'll not be less than the maximum number, the maximum, which is 10. So I don't know. I find this is the best. I find this is the best. They need to digest it. Guys, you're shocked.
Okay, it's a bit confusing. Can I ask?
Yeah.
You
Yes,
said
ask.
it first executes the code, then checks the condition.
Yeah.
So if it's false, will it print or will it just show an error first?
If it's false, it will stop. It will not even print anything. That's why we've not seen 10 here. Remember our condition here is while A is less than, while A is less than
10.
10. Yeah. So 9 is basically less than 10. 10 is not less than 10, right?
Yes.
Very early in the morning, they needed to slaughter.
Anybody else with an observation, maybe? Wanna say something, but don't be afraid.
Hey, my question is if the variable a is to have an equal like b5 and also the variable maxnum b5, will the code run or it will totally not even?
It will not. I think I'm pretty sure it will not, because like there will be nothing. Yes, otherwise the value is 5. The value is already 5, so like we can't compare 5 to 5. Okay.
Okay.
Yeah. But if we put 0, what do you expect? It will go all the way to 4, because 4 will be the number that's less than the maximum number. The maximum number is 5. So this thing says, in simplest terms, uh, this is like, how do I put it? That do while loop executes a block of statement and then checks the condition. Okay, if the condition returns true, the loop continues. That's why we moved from 0 to 1. Maybe somebody can just say, why didn't we just stop at 0? Why did we have 1 being output? Let me answer. Because this do while executes the first iteration, then checks the condition. If it returns true, it goes to the next one. And our condition here is while f is less than the maximum number. Maximum number is 5. So I can play until I get to the number that's less than 5. So long as I don't touch 5, because 5 is not less than 5. So yeah. I hope it's not strange. I hope it's not strange. I actually find do while the simplest. It's actually the simplest. Honestly, it's the simplest. Right. So jump. I think we only remaining 3. I'm seeing only have like 5, 7 minutes. I hope you don't mind if you extend with 10 minutes or 15. Is your schedule okay? Silence means yes. Remember when maths teachers used to steal your PE lessons? Today I steal it. Jump statements. In that, jump statements control the flow of execution by breaking or skipping sections of code within loops, conditional statements, or functions. Here is a rundown of the most commonly used jump statement. So this one is just like a helper of the do's, the whys, the for loops, switch. Okay. Break. The break statement immediately stops the closest and closing loop. For, while, or do while, or even switch. You remember breaking switch? It's the same break. It actually it stops and then moves to the next part of the program outside that loop or switch. So we can just use our switch because we're used to it. So when you say switch, we add breaks after every case. Okay. So it's just like now differentiating it. This case to the other one. So void main for integer I is equals to 0. Int the same integer integer less than 5, then increment your integer. Okay. Then if I is exactly 3, okay? If I is exactly 3, break stops the loop when it's equal to 3. What do you get? Outputs 0, 1, 2. So these are, I think these are 3 indexes. 0, 1, 2. Break. Zero, 1. You stop when you're at 3. If I add your 4, how many indexes will you to go? 4 indexes. 0, 1, 2, 3. Oh, sorry. 0, 1, 2. And you can see I is less than 5. Wait, there's something that just a moment. Right. Yeah, sorry, I a bit confused this. So, yeah, I just confused the indexes and the item. Okay. I confused the indexes and the item here. So here, this one will, if integer I is exactly 3. So like, it's in short, we're telling this guy, stop when you already have 3 items being displayed. Okay. So is it 0, 1, 2, that's 1, 2, 3. These are 3 outputs. Okay. If I say maybe 5, 4. 1, 2, 3, 4. So it will stop when the loop has 4 items, or when items are exactly 4. Break. So here, I don't really want this break to look more confusing. Just use the break that we used in switch. It's the same break, which said, once I'm done with case 13, I break, then I go to case 9. Break is just like discontinue. Okay? It's like cut that continuation in the simplest terms. continue, and return. That continue. The continue statement skips the current iteration of the loop and proceeds to the next iteration. It skips the current iteration of the loop and proceeds to the next. It is used often within for, while, or do while loops to bypass specific conditions without stopping the entire loop. For example, for integer I is equals to 0, then integer is less than 5, then you increment your integer. So long as you don't get to 5. So if I is exactly 2, continue. Okay. So this continuous keeps this condition that even if it's exactly 2, I'll proceed all the way to where I is less than 5. Hence, the last output is 4 because we have we have the condition that I should be less than 5. And this condition here tried to bar us from proceeding. But what did we use? We used continue. Okay. So continue skips the rest of the loop for I is exactly 2. So it skips this. It skips this condition that if I is exactly 2. The continue says no. Me, I'll not stop. I'll proceed until when I is less than 5. And of course we'll be iterating. We'll be moving from 0 to 1, 0 to 1 to 2, 2 to 3. That's how continue works. Continue is like it breaks the rules. Let's say that. Continue. You see, continue does not really care this condition number 3. It doesn't care. It just proceeds. Yeah. It goes all the way to 4 because so long as we are less than 5, we can proceed. I hope you've seen how continue works. Return. The return statement exists from a function optionally returning a value to the caller. When return is executed, no further code in the function is executed. Return is like a result. Okay. Int sum, int a. Okay. And let's take it. Return. Return is just like result. So integer a. Int sum. Then this function here contains parameters in its parentheses. Int a, comma, and int b. Inside the function, we will return a plus b. Okay. This one will work perfectly when we go to functions, but let's just have a look. Then I'm sure you are shocked. How can't we have our void main function below that we are used to have in the cycle? No problem. It's like this is just let's say an advanced form of it, but we touch this benefit function. So void main, we open our function the same way, print sum. Here is the sum. 3 and 4. Why do we have this 3 and 4? because our function has a parameterized list, A and B. So we have to give this A and B values. This one is on functions, but we just have that rough idea. We'll still tackle it. So we have functions with parameters. We'll have functions with no parameters and return types. Parameters with the return values. So we'll touch on this, but we just have a look. So it's also another way of performing sum or arithmetics. Would say that. Transfer. I think this one is just like a handout because you're not yet here. But feel free to interact with it. Feel free. So return is like just bring. It's bring. Like result, give me the result. Return is just the what? Return the value. I know you're tired. Okay, is it still there?
Yeah.
Yes.
How is it going? Is it getting deeper?
It's getting tough.
It's getting tough. But the economy is doing wonderfully. Yeah.
It's
so
definitely getting tough.
Yeah.
It is definitely getting tough.
Yeah, it should. If it's easy, everybody would be doing.
And can I just make a suggestion?
Oh yes.
Can we have catch-up lessons on Saturday in the evening?
Yeah, I can create time. We'll talk, guys. Saturday, it's weekend is family.
Saturday we are in church, bwana.
Saturday bana, I know.
Alan?
Kanisa bwana.
Alan?
Okay, I suggested Saturday because on Wednesday there's man. There's catch-up sessions for man, so I don't know. That's why I suggested
church. SDA.
I think what we'll be doing.
Alan?
We are already in our WhatsApp group, right?
Yeah.
Alan?
We can be organizing some small catch-ups.
Alan?
Yes.
Okay, you hear me?
Yeah. Tapelo Makgak.
Tapelo Makgak. Yeah, I just wanted to ask something. The sessions, the morning session and the midday session and the last session, are they the same or do you do different things on all the sessions?
They are continuations, guys, because now we are recording it. So in case you miss the first one, you will get the recording.
Yes. So are they the same? Is it the same thing?
No. They are continuation.
Oh, okay, no problem.
Yeah, like each week we have lesson 1, lesson 2, lesson 3, lesson 1, lesson 2, lesson 3, lesson 1, lesson 2, lesson 3.
Oh, okay, man, I see. Thanks, man.
Yeah, Makaga. That's it.
Excuse. Just a quick one. Are we supposed to attend the other classes all them? Like man, AI, all those?
If you specialize in man, attend it, but if you have time, attend all of them. Like, you are not really stopped from attending any class as long as you ensure you attend the one that you specialize so that your project can have something based on what you chose.
But now if you attend like 2 specializations and then you successfully complete all of them, are you gonna get certificates for both or just the one you specialized in when you signed up?
That one, I can ask our dean of students.
Oh.
Yeah, I can ask our dean of students.
I think
I'm
that
sure
we
in
were
the form you are told to choose one.
We were told that you will only get recognition for the specialization line.
Yeah, we are trying to avoid people chewing more than what we can swallow, because I remember there was a student who did more than 5. Yeah, you can complete 2 modules, guys. If you have time and commitment, you can. But now we are, it might be 1 out of 50 people. So the rest of the 50, They are neither satisfying this module nor that module. So where are they? See? That's when now we decided let's just restrict. Let's touch on the last one, then we talk. Please, okay? So assert. The assert statement is used in development to enforce certain issues. To assert is basically to ascertain or to enforce. If the condition is false, it stops the execution of the code and throws an assertion error. Although not strictly a jump statement, it helps enforce control flow logic during development. This one you might never use it, but just know it. So void main integer age is 18. Assert age is greater or equal to 18. So here age must be at least 18. So this is just like confirming the value of the variable to ascertain the value, to enforce the value of the variable. Assert. So void main integer age is 18. Then now we want to confirm. We'd have just done this. Let me remove the assert first. Let me just print. You are 18 years of age. You are 18 years old. So it still runs. But now we want to assert. We want to make it very true, like very, very true. Very true. Okay. You see, you're still getting the same output. But this guy has already gone inside and confirmed that it's actually true. Let me put this 11. What do we get? An assertion error. Age must be at least 18. Let me put 19. You're 19 years old. So that is it. So assert is just confirming that you're confirming this value of this value. You are really, really, really confirmed. Like it meets this condition. So you see, the way you proceed, the more it gets easier. Yeah, it gets easier. I want to assure you that. And that brings us to the end of week 1, or rather, our day 1. We captured the intro, data types, control flow. Now my work is now to put the recording and resources in lesson 4, so that in case you missed the first 2, you will still be able to be at par with the rest. So that is it. Thank you so much. Allow me to stop recording and we can chat a bit.